So when we're presented with a left bundle branch block, the question that we need to ask ourselves is the law of appropriate discordance there? So the easiest way to explain this is the law of appropriate discordance just means there should be opposites. So what that means is that if you have a negative QRS complex, you should see some degree of ST segment elevation or the J point going back to the isoelectric baseline. And then the vice versa is true. If there's a positive QRS complex, there should be some ST segment depression or the J point goes back to the isoelectric baseline. This is all part of a normal left bundle branch block. So what do we see here? We see negative QRS complex, some degree of ST segment elevation, totally normal, right? In V4, QRS is negative, goes right back to the isoelectric baseline, completely normal. Now one thing, and the reason I liked this 12 lead is I wanted to point out in AVR, where is our J point? And if at any time that you're asking yourself this question, is that notching on the QRS complex, where is the actual J point? One thing that I like to do is in this case, in AVR, you can look at the lead directly below it or above it, depending on whatever lead you're looking at. So let's look at AVL. We can clearly see that the J point is here. So if we take a line all the way up, that is actually your J points. In AVR, we see a negative deflecting QRS and a J point that goes back to the isoelectric baseline. So this is all part of a normal left bundle branch block.